Okay, today in class we talked about the roots and radicals. Okay, so section 6.1, and now we're on keep going on with this. Now we're working with finding the nth root and simplifying radical expressions, which these are very similar to what we've done already. All right, what is the nth root? So what we're looking for is if I have the for instance, if I have the square root of b, I'm looking for what number times itself. Let's go a times a, which equals b. So it's going to be two numbers and multiply and make that. So for instance, if I take the square root of 25, that's 5 times 5. And so this is equal to 5. So some number multiplied by itself to make that. So then if I go to the next one, the cube root. So if I want the cube root of b, well, that's a times a times a. So what number times itself 3 times is equal to that particular value? So if I take, for an example, if I take 8, well, that is 2 times 2 times 2. So the third root of 8 is 2. The fourth root, well, that's the fourth is my index, and we'll put b here, and that's a times a times a times a. All right, so let's talk about this. Let's say I want the fourth root of 16. Well, that's 2 times 2 times 2 times 2. This is 2. Okay, so that's what the roots are, and that's what we're talking about in this case. And obviously we can go up from 4, but we're not going to mess too much more. Maybe 5, but that's about it, not too much. So perfect squares. I would suggest that you know your perfect squares 1 through 15. So for instance, if I take 15 squared, that's 25. That's 225. And therefore the square root is 225. If I take 14 squared is 196, 13 squared is 169, 12 squared is 144, 11 squared is 121, and then so forth. So you should know all those. Those are the ones I know. Now remember, when I talk about the square root of 121, I know, look at, hey, that's going to be 11. Perfect cubes. Now the perfect cubes, those are okay. We're going to multiply the number times itself 3 times. I know 1 through, I'm going to say 6. Really 1 through 5. So 1 to the third is 1 times 1 times 1. That's 1. 2 to the third is 2 times 2 times 2, which is 8. 3 to the third, well, that's 3 times 3 times 3, which is 27. 4 to the third, I'm going to skip that part right there because that is 64. 5 to the third is 125. 6 to the third is going to be 6 times 6, 36. 36 times 6 is 216. Now, these are just the numbers. I really think that if you know these, it sure does help you out. It just makes it easier and faster to do these without having to use a calculator. Now, perfect fours. Hey, I don't know very many of these. I'll go up through 5, maybe 6 on a good day, but definitely 5. So 1 to the fourth, I'm all over that. 2 to the fourth. Well, the good thing about this is you can put these together in pairs. This is 4 times 4, 16. 3 to the fourth, well, that ends up to be 9 times 9, 81. 4 to the fourth. Now we're getting a little bit more tricky. That's 16 times 4 times 4, so that's 256. 5 to the fourth. That is 625. And I take that back. I don't know 6. Okay, so those are numbers I would suggest that you make sure that you know all the time. The bam, 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 bam. I can get you those really quickly. I know what those answers are right away. Okay, but those are the ones that I kind of use. Those are the basis for this. And then when I try to simplify this, I use these numbers all the time. These are the ones I try to find and try to use every single time. Now, if n is odd, I get one solution. So what I'm trying to say is, if I take the third root of 8, let's even make it negative 8, then this is going to be negative 2. So in this case, n in this case is right here. And so I can get one answer. I don't care. Oh, this is n, sorry. If n is odd, you'll get one solution. So it'll be that. This can be positive, negative, it doesn't mean. If it's even, though, you'll get two solutions. And we've already played around with this a little bit. So if I take the square root of 25, now don't forget, 5 times 5 works. So that's 5. But also, negative 5 times negative 5 is 25. So that would be both positive and negative. So that's why I get that positive and negative. Now, the rule that I always use, if I put the square root, if I add the square root, if I'm taking the square root in my problem, then that tells me that this is going to be a plus or minus situation. If it's in the problem, like today, the square root is going to be in the problem, then it's just the positive, just the principal root. Okay, so the principal root of this one is 5. Okay, if n is negative, there are no real roots. Okay, so now what that's talking about is if I have the square root of negative 25, okay, square root of 25, square root of negative 1, this is 5i. Okay, so now I can do that way. Now, this isn't real. This is a imaginary number, so it's not real. So that's why I end up that way. But now, when we're asked, if they ask for real roots, then we'll have some that will say no solution because there aren't any. Okay, the fourth root of 16. So I'm going to write that as the fourth root of 16. So what times itself 4 times is 16? Well, 2. The correct answer will be plus or minus 2 because I'm adding that. Now, but really, I'm going to be happy with 2. Now this one, I want the third root of negative 8. So that's negative 2. And then I want the fourth root, the square root of negative 121. Well, that's negative. That's no solution. And then finally, I want the third root of 64. Okay, so 4 times 4 is 16. That's going to be 4. Okay, radical problem symbol and within is okay. So that I've been showing you the symbol all the time. So when I do this, right here, this is called the index. If the index is 2, it's not written, but otherwise it'll be there. This number right underneath here, this is the radicand. This is the number that we're taking. So in this case, now this is actually makes a lot of sense. If I want to find the square root of 25, what that is that's the square root of 5 squared. Well, that's 5. These two, this is saying I want 5 times 5, and the radical symbol is saying, hey, what number times itself makes that? So it ends up just a wash. So these two things, as long as these two things are the same, the answer is always going to be that. If it's odd, yes. It's even, this is that whole plus or minus thing. Now, as I look at this one, okay, the square root of 24. Let's break that down. I think that's going to be 4 times 6. Now, exponents. This is it. So I want to take the biggest even, and I'll add those up because this is a index of 2. So I want to be able to divide this by 2. Same thing there. So now I get 2x squared y to the second square root of 6x. The exponents add up to make this one, and then I just divide these exponents by the index 2. All right, now we have root, third root. Now, whenever I see 1,000, that kind of makes me start to think, that's not like 10. Well, it actually is. And now notice that this is a 3. So by what we just looked, what number times itself makes x to the third? Well, these two numbers cancel each other off. This is actually an x. And what I do is I just divide this into each one of these. So this actually is a perfect. It's a 10. X to the third is a perfect. That's just x. And then I take 9 divided by 3. That's 3. So there we go. Here we go with this 16. Okay. That's a perfect. This is divisible by 4. This is divisible by 4. So I end up with 2, because 16 is 2 times 2 times 2. I'm going to divide 8 divided by 4 is 2, and 4 divided by 1 is, divided by 4 is 1. Now, what happens if I take something like 32, let's go to the 4th, x to the 10th, y to the 6th. Now I'm going to do this similarly to what I did before. I'm going to look for a biggest perfect fourth power, which I think that's 16 times 2. 16 times 2 is 32. How many times does 4 go into 10 evenly? Most is 8 times, leaving 2 extra. Here, I'm going to take out 4 of those, but I'm left with 2 extra. Okay, the fourth root of 16 is 2. Divide these. Divide these. This comes along for the ride. Now, I don't know if you have any of these to do today or not. So there you go. That's the lesson for today. You have that assignment. Have yourself